All right, hello class. Welcome to this video on the cycle assessment practice tasks. So we're going to cover the problems from the the practice quiz that is on Canvas. So let's go ahead and get started. There's quite a bit of questions here, so this might be a longer video than usual. So first off, we want to match the word to its definition. So we got a couple of vocab questions in that practice. So you got to know what a point is, a line is, and so on. So a point is generally a location in space. It has no definite size or definite thickness or anything like that. So point here, it names a location in space and has no size. A line is extends forever in both directions, in two directions, right? In one direction and in the exact opposite direction. So it's a straight line path that extends forever in two opposite directions. The plane is generally like a flat surface. You need 3 points for a plane at least. It extends forever without end and has no thickness. So that's a plane. Segment is part of a line. So it has two endpoints. So we have part of a line that consists of 2 points, which we call the endpoints. Ray is essentially it's part of a line. It's like half of a line. So it consists of one endpoint, then it extends forever in the one direction, right? And then this is the line segment, kind of looks like this. Plane, flat surface, a line like this, and then a point is just a location in space. Okay, so we have array is part of a line with one endpoint, and then all the points extend on the other side. Angle. An angle is formed by two of these rays. If we put two of these rays together and connect them at one point, we call that an angle. So formed by two rays, the same endpoint. Now let's look at the next definitions. So we have parallel lines. So kind of look like this, right? These are lines that never cross. So lines in the same plane that never cross. Perpendicular lines, these do cross, but they cross at a specific angle. They cross at a 90-degree angle. So these are lines that form a right angle. Midpoint, point that divides a segment into two congruent segments. So remember, midpoint, if you're trying to do a midpoint of something, it generally cuts it in half. So the midpoint is the point that cuts the figure in half. So essentially the same distance on both sides. So it divides a segment into two congruent segments. Okay, so here, the distance along a line. So this is just plain distance. Remember to calculate the distance. It's the absolute value of the difference in whatever coordinates you're doing. X1, X2, Y1, Y2. You just subtract the coordinates and then that gives you the distance. All right. So now we're done with the definitions. Let's go to the next question. Identify the relationship between each indicated pair of lines as either parallel, perpendicular, or neither. So here we have 4 lines, right? 3 lines that are, or 2 lines here that 3 lines that are crossed, that are intersected by what we call a transversal. So line J and K. So if we're talking about line J and line K, are those 2 lines parallel, perpendicular, or neither? Well, if you look at the lines, you can see that J and K cross, so they're definitely not parallel, but they also cross at a 90-degree angle. And what did we say earlier? We said that perpendicular means they cross at a 90-degree angle. So these guys are perpendicular. Line N and line M. So if you look at these 2 lines, they kind of look parallel. How do we prove that they're parallel? Well, if you want to prove that they're parallel, you're looking at these 2 angles. So these 2 angles, it turns out, if you have any pair of parallel lines cut by a transversal, these angles right here, if this were 70 degrees, then this would also be 70 degrees if they're parallel. However, if this is 70, then this has to be 110 because these 2 angles make a half circle, right? It's called a straight angle. and so they add up to 180 degrees. So this 70 and this blue this blue angle adds up to 180. And so these add up to 180, and so this has to be 110. And so then if you notice, you should then notice that, well, then if those add up to 180, that means these add up to 180 as well, right? 110 plus 70 is 180. So it turns out that if you have a pair of parallel lines cut by a transversal, the angles here, the same side, these are called same side interior angles, they add up to 180 if they're parallel. And if you notice then, well, 71 plus 109 is 180. And because it's equal to 180, that means they're parallel. If they did not add up to 180, that means they're not parallel. So here, we're going to go ahead and say that yes, they are parallel. Lines N and line M. All right, so now this one, we have, if angle 1 is congruent to angle 2, can you conclude that any of the lines are parallel? So this is kind of like what we just talked about. So those two are equal. And just like I said, that if these two were equal, those are called corresponding angles. So let me go ahead and erase this. So these guys right here, they're called corresponding because I can take this angle and I can just shift it down and it's the exact same angle. Okay, so those angles have to be the same if you're dealing with parallel lines. Let's call these lines N and M. So here we're doing line, these two angles have to do with P and N because we're dealing with these lines right here. Those are the lines that we're dealing with whenever we're dealing with those angles, right? And the transversal that we're dealing with is this guy. Okay, so that is the figure that is relevant to angles 1 and 2. So, well then, is N and P, are they parallel? The answer to that is yes, because these two are equal. Okay, so if angle 1 is congruent to angle 2, that means N and P are parallel. So N and P are parallel because corresponding angles are congruent. We said that those are corresponding angles. All right, let's look at the next question. So given the above theorem, determine the relationship of the angles below if angle 1 and angle 2 and angle 4 are supplementary. So here they give us what we call a congruent supplements theorem. And so that states that, well, if we look at the picture here, so if angle 1 is supplementary to angle 2, which it is, if you think about it, you know, these are supplementary. If I move this over, right, then I get something like this, right? And we know that if they add up to a line, that's 180. Okay, so we know that angle 1, if I move it and slide it over, it's gonna make 180. And the same thing with angle 3. We know that for angle 3, if I slid it and moved it over, well then it's gonna make it 180. It's gonna add up to 180. So if angle 1 is supplementary to 2, angle 3 is supplementary to 2, well then that means that these two angles are identical, right? That's just saying that angle 1 is the same as angle 3. That kind of makes sense. So so basically, based off of that theorem, we want to say, well, is angle 1 and angle 4, are those supplementary? All right, so, well, in this case, they're talking about angle 1 and angle 2. So let's talk about angle 1 and angle 2. So we know that angle 1 and angle 2 form a 180. It's called a linear pair because, you know, they share a side, this side right here, and they add up to 180. So they definitely add up to 180, which means that they are supplementary. Remember that a straight line has an angle of 180. A straight angle. We call this a straight angle. And so if I were to cut it like I did here with angle 1 and angle 2, well then they add up to 180 if you put them together. And so if we look at angles 3 and angle 4, then we can see that they also add up to 180 because they share that side and then they add up to a line. So this is also supplementary. Now let's look at the relationship of angles 2 and angle 4. So if we want to look at angle 2 and angle 4, well, we know that these add up to 180, right? These two add up to 180. So what is angle 2 and angle 4? Well, angle 2 and angle 4 have to be the same. And that's because angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4, and angle 1 and angle 3 are the same angle. Angle 2 and angle 4 are also the same angle. Notice that they're the same exact angle. So they're congruent. Angles 1 and angle 3, they're the same exact angle. We call those corresponding angles, right? If I take that and I slit it over, it's the exact same angle. Nothing has changed. And so those are corresponding angles, and corresponding angles are congruent. All right. So let's look at the next thing. Now we want to fill in a 2-column proof. We have a statement on the left side, reasons on the other side, just like it usually is in a 2-column proof. And so we have a word bank here that we want to use. So we want to draw from this word bank. So remember that the reason for the first statement is almost always, in fact it always is, a given. Okay, so basically that x is parallel to y because that is given in the statement. Okay, so that one's pretty easy. That one's going to be given from the word bank. All right, so now statement number 2 states that angle 3 and angle 8 add up to 180. So let's go look at it. So angle 3 and angle 8, these guys right here. So what kind of angles are angles 3 and angle 8? Well, if you recall, they're interior because they're inside. So they're inside the sandwich in our analogy. So this is like our sandwich, our bread, and then we have our, skewer or toothpick, whatever you want to call it, that cuts through it. And this is inside the sandwich, right? So this is inside. These are interior, and they're on the same side of this yellow line. So they're same side interior. And so based off of the same side interior angles postulate, they add up to 180. Okay, so they were added to 180 because of same side interior angles. So we'll cross that out and use it. Okay, so now the number 3, angle 5 and angle 8 is equal to 180. So angle 5 and angle 8. So now we're looking at this and this. So why did those two add up to 180? Angle 5 and angle 8. Well, if you recall, they're a linear pair. They share a side. They share this yellow side, right? And they add up to this straight line, which is the red line here. And so they add up to a half circle, which is 180 degrees. So this is why we said that they're 180. So let's look at the reasons here. So because they're a linear pair, right? Just like here, let me go ahead and redraw it here. We know that they add up to 180. So when they add up to 180, well, that's another way that we can call it is angle addition postulate. Angle 5 and angle 8, angle 5 plus angle 8 has to add up to 180. So that you can also call it an angle addition postulate because we're adding two angles together. But also, you can also, sometimes they'll call this linear pair theorem. So be aware of that. Sometimes they'll say angle addition, sometimes they'll say linear pairs theorem or something like that. But if they say that, it means the same thing. They're meaning the same thing here. Okay, so we're looking at angle addition postulate. So let's use that for here. Okay, so now if you look at the fourth reason, it says the transitive property of equality. So the transitive property of equality, if you recall, is if A equals B and B equals C, then that means that A equals C. Okay, so if A equals B, B equals C, well then that means A equals C, right? So that's the transitive property in a nutshell. So if we were to use that transitive property for step 4, well that would look like this. Well, we have angle 3 and angle 8 is equal to 180, so that's A. think of 180 as B. So if A equals B and B equals C, well then that means that A has to equal C, right? So these two underlined portions have to be equal to each other. And so statement 4, we'll go ahead and say measurement of angle 3 plus measurement of angle 8 equals measure of angle 5 plus measure of angle 8. Sometimes they'll call this substitution property, but other times they'll call it transitive property. Either way, they mean the same thing here. You're either doing a substitution where you're thinking this, where you're replacing the 180 with this, or you're doing a transitive property when you're setting them equal to each other. Okay. So here we got step 4. Now the next step, we want to do a subtraction property, which means we're going to need to subtract both sides by the same number. Well, the same number here is angle 8. You see that we have angle 8 on both sides. So we're going to subtract by the measure of angle 8 on both sides. And I'm showing the work here, but you wouldn't actually write this on the paper, right? It's just to show you the work. So these cancel, and then you're left with angle 3 is equal to angle 5. So the measure angle 3 is equal to the measure of angle 5. All right, and so now we know that the two angles are equal. 3 is equal to 5, the measure. And so we're going to go ahead and convert this to a congruent statement and say that angle 3 is congruent to angle 5. Okay, so if the two angles are equal, well then that means that they're congruent. And that's the definition of congruence. And so notice that we were able to prove the final statement. Right? And of course, you know, I crossed these out. I've used these parts in the bank. All right, so let's look at the next one. So complete the two-column proof to prove the alternate exterior angles theorem. Okay, so we have, again, another word bank. So it says we're given that K is parallel to L. So now, how did we get that angle 1 is congruent to angle 5? So angle 1 is congruent to angle 5. Well, if you notice, what kind of angles are angles 1 and angle 5? Angle 1 and angle 5 are corresponding angles. If I were to take this angle and slide it over, it's the exact same angle. And so that's a corresponding angle. All right, so by corresponding angles theorem, those are congruent. And then we can fill in the last point, transitive property of congruence. So transitive property, remember A equals B, B equals C, A equals C. Well, this is the transitive property of congruence. So instead of using the equal sign, it's just using a congruent sign. So if A is congruent to B and B is congruent to C, well then that means that A is congruent to C. Okay, so we're going to use that here. 1 is congruent to 5, 5 is congruent to 7, well then that means that 1 is congruent to 7. And that's the transitive property right here. Cross those out, we used them. All right, next one. What value of x would make u parallel to v? So we want these to be parallel. And so if we want them to be parallel, well, these are alternate interior angles. Okay, so the angle pair here is alternate interior angles because this is my sandwich, and you know, if you think about it as a little sandwich, and then this is my toothpick or whatever you want to call it, whatever cuts through that sandwich, and then they're on opposite sides, right? And they're also inside the sandwich. Okay, so they're inside our diagram, and so they're alternate interior angles. And because they're alternate interior angles, we know that they're equal. You have to know that alternate interior angles are equal. Always going to be equal. If you think about it, this angle is an obtuse angle, or is an acute angle. It's really tiny angle right here, and I'll emphasize this for, more here. So if you look at this angle is an acute angle, very tiny. This angle is also an acute angle. It's very tiny. If these two lines here are parallel, then those two angles are going to be the same. Now, if you look at these ones here, this one is obtuse. It's a big angle. This one is also obtuse. And so those guys are equal. Okay, so that means that this is equal to this. Those two are equal to each other. So alternate interior angles are always equal. And so we can go ahead and set those angles equal to each other and then solve. So we'll go ahead and let's go ahead and move x to the right side by subtracting the 7x. So we got 8 minus 7 is 1. So this is 1x plus 6. We'll subtract 6 on both sides. So x is equal to 8. All right, so value of x is 8. All right, next problem here. Okay, so for the next problem, select all the true statements given the following triangle. So, okay, so we'll just circle the ones that are correct, or place a check by them. So let's see here. Select all the true statements. We have 3 angles. We have 2x plus 1, x plus 15, and x. So let's look at the first statement. 2x plus 1 plus x plus 15 plus x equals 180. Is that true? So basically what they did is they added these 3 angles. Notice that. So is that true? If we were to add those 3 angles, does that give us 180? And the answer is yes. Remember, the triangle angle sum theorem states that if you add any 3 angles in a triangle, they add to 180. So if this were 60, this were 50, well then that would mean that this is 70. Okay, so 50 plus 60 is 110, 110 plus 70 is 180. Okay, so this always works for any triangle. So that means if we add these 3 angles, this one is that first one, this one is the second one, this one's the third one, they will add to 180. So that's true. So we'll circle that and check it. And then 4x plus 16 is 180. Is that true? Well, let's see here. Let's see if that's true. Well, what they did is let's see if we combine those. What do we get? 2x plus x plus x. That's 4x. 1 plus 15 is 16 equals 180. Is that true? Well, yeah, that's exactly what we got. So that's true. X equals 49 or x equals 41. Is that true? Let's solve this and find out. So let's subtract 16 on both sides. And then so we can solve for x. So 180 minus 16 is 164. Then we'll divide by 4 on both sides. And that's going to be 41. Okay, so it's definitely not 49. So let's cross that out. It's 41. The measure of angle 9 is 99 degrees. Okay, so, or angle A is 99 degrees. So angle A is this guy, right? So let's go ahead and plug in what we found for x into here. Because remember, this is equal to x, right? This is 2x plus 1. So let's plug in x in there. So 2x plus 1, 2 times x. X is 41. Plus 1. So 2 times 41 is 82. 82 plus 1 is 83. So is that equal to 99? No. So that's not equal to 99. So we'll cross that out. From the smallest to the largest, angle B, angle C, and angle A. Okay, so angle A we found was 83 because we just found it here. So the measure of angle A is 83. Now let's find angle C. We'll plug in x there. So that's going to be 41 plus 15 equals, x was 41, yeah. So 41 plus 15 is 56 degrees. So the measure of angle C is 56 degrees. And then x is just 41, right? So the measure of angle B is 41 degrees. All right, so B is smaller than C, and C is smaller than A. B from smallest to largest, B, C, and A. So that's true. Measure of angle C is 56. Yes, we did. We found that and we got 56. So that is true. All right, so next problem. We have a triangle diagram. We have an exterior angle. This is an exterior angle Remember, an exterior angle is when you extend one of the sides of the triangle straight forward, or straight out, and then you're measuring the angle to the next side on the triangle. Okay, so the value of x. So remember that when you're doing an exterior angle, there's a theorem known as the triangle exterior angles theorem, and that states that if you wanted to find angle 1, the exterior angle, well, then you're going to have to add the remote interiors. So in this case, you're going to have to add 2 and 4, the ones that are farthest away from that exterior angle. Okay, so this is my exterior angle, 8 plus 6x, and that has to equal, so let's write it out here. This is what the theorem says. The measure of the exterior equals the measure of the remote interiors. So those are the remote interiors. So 8 plus 6x is angle 1. Angle 2 in this case is 30, so it has to be 30 plus angle 4 in this case is 4x plus 2. So those are my remotes. So we add those together, and then we have an equation that we can solve for x. So 30 and 2 is 32. So we have 8 plus 6x equals 4x plus 32. Let's go ahead and subtract 4x on both sides just to get rid of the x on the right side. So 8 plus 2x equals 32. We already moved x to the left side, so let's move this number out of the way by subtracting it. So we have 2x equals 24. Then we divide by 2 on both sides. So x is equal to 12. Okay, so we got x is 12. And so now that we got x is 12, what is the measure of QRP? So QRP is, so this is QRP. So you want to figure this angle out. So to find that angle, well, I mean, we already know what these angles are, right? Because we know what x is. X is 12. So if we plug in 12 there, that's 4 times 12 plus 2. 4 times 12 is 48. 48 plus 2 is 50. So this is 50 degrees. So let's replace this with 50 degrees. So that's 50. That's 30. Well, if on a triangle, all the angles have to add to 180, right? So we have 50 and 30. And whatever that angle is, let's call this y for a variable. And that has to add to 180. So 50 plus 30 is 80. And then 80 plus 100 is 180. So this has to be 100. All right. Let's look at the next question. So what is the first step in the construction of an angle bisector? So draw an acute angle PQR, then construct its bisector. What is the first step? So remember that when you have an angle, so let's say angle PQR, if you want to bisect this, well, what you're going to have to do, usually what you do is you make an arc, right? You would make an arc with the compass like that. So let me do that in another color. So you would normally make an arc with the compass like this, right? So let's say this is your compass like that, and then you make an arc by rotating it this way. And then once you do that, you take the arc or the compass, and then you make another arc with it by placing it at point P, and then drawing an arc this way, and then you place the compass on R, and then you draw another arc this way. And so when you do that, you end up getting, so let me erase the compasses now. This is just my funny little drawing of the compass. So then once you make those arcs, then you can connect them by a straight edge, and then that will be your bisector. So notice that the first step here is you have to draw this arc, right? From P to Q, P to R. But let's assume that it's already drawn. If it's already drawn, then the next step would be to do what we did here and place the compass at P and R and make these arcs here. Okay, so let's look at the questions and see if we can answer it. So what is the first step in constructing? So put the compass point on vertex Q. Draw an arc that intersects the sides of angle PQR. Label the points of intersection A and B. Okay, so basically what they said is that, well, we have an angle PQR, right? We already have that angle. How do we do the first step then? Well, what they did is, okay, well, they put the compass on Q, and then they adjusted the compass however way they like. They didn't adjust it to P, they adjusted it to somewhere else. And then they drew an arc. Okay, so then they drew an arc, and then they labeled that A and B. Okay, and that was essentially what I told you needed to do. You needed to take the compass and then draw an arc. The arc may not be P and R, it may be somewhere else. Okay, I just happened to draw it in P and R. Okay, so label the points of intersection A and B. That looks good. Put the compass on point P and draw an arc. No. Put the compass on point R and draw an arc that intersects QR. That's not the first step. So the first step is this guy. You have to draw that arc first. Draw that arc first, and then do this first arc, and then you do the other arcs after it, like the ones that go like that. All right, what is the first step in copying an angle? All right, so if you wanted to copy an angle, remember that if you have an angle, let's say like this. Okay, so let's go ahead and go over the steps. So the first thing that you want to do, let's go over all the steps so you can refresh your memory. So the first thing you want to do is normally is you would use a straight edge. So let's say this is my ruler, right, or some kind of straight edge, and you use it to draw a straight line. Right, like that. Okay, so that's the first step. You use it to draw a straight line. And then next you would, and then we'll label this. Let's label this D or something. Then you would use your compass, right? So let's pretend that this is my compass. And I would use that compass to draw an arc like this. Well, I would draw it on here first. So what I would do is I would use the compass and draw an arc, that goes through this. And then we'll label that, say, A and B or something like that. And then I would keep that setting, right? I would keep that setting and do the same thing here. I would draw an arc and then I would end up drawing that arc. Okay, so I end up drawing the arc, and this arc, I'll call it E. And then what I have to do, so let's say I draw a nice size arc. And then next thing I want to do is I want to take the compass and I want to measure between these two, because I want to see how far that distance is. I want to measure it out. And then I'm going to keep that setting, and then I'm going to go to point E, right? And then keeping that setting, I'm going to draw an arc that kind of goes like this. And then when they cross, so now we can tell that they cross. Then I'll go ahead and use a straight edge and connect those. And then I would get my angle. Okay, so that's the general steps for constructing it with, like we normally would. So basically the first step is you have to draw one of the edges, okay? So with a straight edge. So draw a segment, a line segment with endpoints C and D. Plot points C and D, and then draw a ray through them. Plot points C and D and draw a line through them. Draw a ray and label the endpoint D. So that's basically what you're gonna do. You're gonna draw a ray here, and let's see, and then you can label the endpoint D. So that's exactly what we did. We drew a ray with a straight edge, right? And then we labeled the endpoint something. D would be the obvious choice because D is right after C. Okay, that's the one that we're looking at. All right, construct the perpendicular bisector of AB. So assume the segment AB has already been constructed. What is the first step to construct a perpendicular bisector of AB? Okay, so let's go over those steps again, for the bisector, because we haven't gone over that yet. So let's say that's line segment AB. First thing you want to do is you want to adjust your protractor so it's so that the distance of it is a little bit greater than halfway through the line segment. So a little bit more than halfway through that line segment. So like, let's say like this. Then I'm going to draw an arc with that line segment this way. And I'm going to draw it this way as well. Okay, so I'm going to draw an arc above and then an arc below. And then keeping that setting, I'm going to put the point on B. And this right here is, so the point here, I'm going to say that this is the point. Here, let me redo that again. So this is the point on the compass, and then the arrow is the pencil end, okay? The point is here on B, the pencil end is here. And then I'm going to draw another arc this way and an arc this way. And once I draw those, oops, I erased the arc by accident. Let's go back. Okay, so let me erase just the compass now. There you go. So then once I make those two arcs, wherever they cross, is where I'm going to connect my line. Then I connect it with a straight edge. Okay, and that's how you make the perpendicular bisector of AB. So those are the steps. Okay, so put the compass point, so let's evaluate the steps here. Put the compass point on A and then draw a long arc. Be sure the opening is greater than 1/2 of AB. That looks good. That's basically what I was saying. Make sure that the opening is greater than half of AB. So let's look at the other ones. Open the compass to half the length. No, not half. You want it to be greater than, so not that one. Open the compass point to 1/4. No. Put the compass point on point A and draw a long arc. Make sure the opening is less than. No. So we're looking at this one. All right, so what is the first step to copy a line segment? So line segments, copying them is really simple. So if you wanted to copy this line segment AB, for example, well, first you're going to use a ruler or a straight edge. Use a straight edge, and then use that to make a line, a line segment, I mean. So just make a nice little thing like this. You're going to make a line, but then it's going to cut it into a line segment. We'll label this endpoint something, whatever. And then we're going to use the compass to measure how far away it is from A to B, and then use that here. So the point of the compass is on C, the pencil end is here, and then you're going to draw an arc. And then that means that this point right here has to be your other endpoint, which would normally be B, but we call it D here. And then we can erase the rest of it, and then we have our arc, or our line segment. So it looks kind of like that. So basically the first step is you need to use a ruler to draw a nice long line. So use a ruler to draw line L and label the point M. Use a straight edge. Okay, so straight edge. Place a compass point at X and open the compass to length XY. Yep, open the compass to length XY. That's true. Using the same setting, place the compass at point M, draw an arc through line L, and then mark point N as the intersection. That's basically what we were saying, is that this was your long line, keeping the same setting here. You want to draw an arc and then label it whatever you want to label it. In this case, I call it D. They ended up calling it N. So that's fine. With a setting greater than 1/2 XY, place the compass. No, that's not it. That has to do with perpendicular bisector, not with line segments. All right. The next one is, what is the equation of a line that is perpendicular to the line y equals 2x plus 1 and passes through 0.46? All right, so perpendicular means the slope is an opposite reciprocal. Opposite or negative, we call opposite negative, same thing. Negative reciprocal. So what that means is if my slope was 1/2, or if my slope was 1/3, I would flip and then change the sign. So if it was negative here, this turns to positive, and vice versa. That's what we mean by opposite reciprocal. So the slope here of this line, this is y equals mx plus b. That's called the slope-intercept form. This is my slope. This is my y-intercept. So clearly, the slope is 2 based off of that description. So slope is 2. And so if I want it to be perpendicular, well, I need the slope to be opposite reciprocal, right? So I'm going to put this over 1. I'm going to flip it. And I'm going to change the sign. This one's positive, so it's going to become negative. So this is my new slope. Okay, so this is my new slope m. We'll call it m because m is the symbol for slope. So now we're going to use our equation y equals mx plus b. And we know that m is now 1 negative 1/2, right? So there you go. So now we are down to 2 options. So which one is it? Well, to find it, we need to find b. To find b, we're going to use our coordinates that they give us. So it says that the line passes through 4, 6, right? So that's x, and this is y. Let's go ahead and plug that into this equation. Y, x. So y is 6, x is 2, or 4 rather. I thought it was 2, it was 4. So y, which is 6, equals negative 1/2 times 4, because we're timesing it by x, plus b. And then half of 4 is 2, and a negative times a positive is a negative. So this is a negative 2. So then we have to add 2 to both sides to solve for b. And so b is 8. So there you go. We got b. B is 8. So clearly, or no, that's not the right one. Sorry. B is 8. So this is the one that we want. So clearly, this is the one that we need. All right, determine if the following lines are parallel, perpendicular, or neither. So first you need to convert these to slope-intercept form. Y equals mx plus b. So we got to convert it to that form. So if I want to do that, that means I need to solve for y. So I'm going to get rid of this x here right now by subtracting it on both sides. So I get y equals negative x minus 2. Notice I wrote the negative x first, and then I wrote the 2 last. So I brought the 2 down next to it. All right, so there you go. Y equals negative x minus 2. So then the slope here is an invisible negative 1. So that's my slope. And then this one, we need to do the same thing. So we got to, let's solve for y. So get rid of the 4x. So we have 4y equals negative, write the 4x part first, negative 4x. This is a positive 16, so plus 16. Then we divide by 4 to get rid of this. So y equals 4 divided by 4 is 1, but it's a negative. So negative 1x plus 4. 16 divided by 4 is 4. Notice that the slopes are the same. Slopes are equal. If the slopes are equal, that means that the lines are parallel. So we have to say that the lines are parallel. All right, next one. What is the equation of a line parallel to y equals? Parallel means same slope. We just did that. The slope here is this guy. So we're going to be using that same slope. So that means that our equation looks like this. We don't know what b is, but we do know that the slope is negative 1/4. I can write that right off the bat. So equation of a line that's parallel to that passes through this. Okay, so we got a coordinate. We got y and we got x. X is 2, y is negative 3. So let's plug in 2. Let's plug in negative 3 right away. And then this is negative 1/4 times 2, which is x plus b. So again, so for this one, in order to multiply this fraction with this whole number, put this whole number over 1, multiply straight across. 2 times 1 is 2, so negative 2 over, and then, so multiplying these straight across, 4 times 1 is 4. So negative 2 divided by 4, well, this is a fraction. We can reduce this fraction. So let's divide it by 2, top and bottom, and that gives us 1 over 2. So 2/4 is the same thing as 1/2. So 1/2. All right, so we simplified the fraction just to make it a little easier to deal with. This is a b, by the way, not a 6. So we, in order to solve for b here, we have to add the 1/2 to both sides. So b is equal to negative 3 plus a half. What's negative 3 plus a half? Well, you need a common denominator to combine these two numbers together. The denominator of the 3 is 1. The denominator of the 1/2 is 2. So we need these to be the same denominator. So I'm going to multiply this by 2 top and bottom. And so that gives me negative 6 over 2 plus 1 over 2. Negative 6 plus 1 is negative 5. So b is negative 5 over 2. Okay, so we got b, negative 5 over 2. We know what m is. So let's replace this b now with negative 5 over 2. So we can get rid of this minus sign and just write it like this. All right, so that's my new equation. That's my equation. The problem now is that they don't give you that. So that's the answer, but they don't give you that answer in the choices. That's because they wrote the answer in a different way. So we have to basically match this answer to one of these answers. And this is what the EOC will do, the cycle assessment. Even though you have the right answer, you won't be able to pick the right answer unless you match it up. So we're going to have to manipulate this to get one of these answers. Notice that the x and y are on one side of the equal sign. So we're going to move this x over to the left-hand side so that x and y are on one side. Okay, so let's do that first. Let me rewrite the equation because I need space. So I'm going to add the 1/4 x to both sides just so that I can move it over to this side. And so now I have 1/4 x plus y. I just moved the x first, and then this is a positive y. And then bring down the negative 5 over 2. This is almost there because now we have x and y on one side. So now notice that we need to get rid of this fraction. So if I want to get rid of this fraction, I need to multiply by the denominator. So I'm going to multiply by the denominator of 4. I'm going to do that here and here. Okay, so 4 times 1 is 4. So this is 4 divided by 4. Remember, there's an invisible 1 here. So 4 divided by 4 is 1. So this is just going to be 1. So it's 1x. So x. Don't forget to distribute the 4. 4 times y is 4y. All right, what about the right-hand side? This one is over an invisible 1, multiply straight across. So you get negative 20 over 2. Negative 20 divided by 2 is negative 10. All right, so this is what we have. Does it match up with one of the answers? Let's see. If not, we have to manipulate it more. Yes, it does. It matches up. X plus 4y equals negative 10. So see, even though we got the answer before, we had to manipulate it a little bit. All right. Notice that these are in weird formats too. So we're going to have to do the same thing we did in the previous problem here. Find the equation of a line that is perpendicular to this equation and passes through the point 3, negative 4. All right, so we're going to have to basically simplify this. So let's move this. Let's distribute the 2. So 2 times x, and then 2 times 1 is 2 times negative 1 is negative 2. So we distribute the 2 here. We got 2x minus 2. Now we want to solve for y, so I'm going to go ahead and subtract 5 on both sides to get y by itself. So we got negative 2 minus 5 is negative 7. Okay, so we got this in mx plus b. The slope here is 2, right? Just by looking at it. The slope is the number in front of x whenever you put it in this form. How do we get the new slope? Remember that the new slope for the perpendicular, you have to do the opposite reciprocal. So flip it and then change the sign. So it's going to be 1/2. This is positive, so it's going to turn into a negative. So this is the new slope that we're going to use, okay? So instead of y equaling 2x, it's going to be y equaling negative 1/2 x. And then we don't know what this other number is. We don't know what it is, the plus b. So it's negative 1/2 x plus something, okay? So we have to figure out b by plugging in the coordinates that they have here. So this is x This is y. So let's plug that in here. X is 3. Here, I'll plug it into the next step. X is 3. And y is -4. So equals -1/2 times 3 plus b. All right, so put this over 1, multiply straight across. So 3 times 1 is 3, or -1 times 3 is -3. 2 times 1 is 2. Then we'll add the 3 over 2 to both sides. It's just 3 over 2 is just a number. We want to get rid of it, and it's negative, so we add it. So now we have to do, so that's b. b is -4 plus that number, 3 over 2. So put this over 1. Remember, when you combine a whole number with a fraction or fractions, you need to have a common denominator. So the common denominator is 2. So multiply this top and bottom by 2. So you get -8 over 2 plus 3 over 2. -8 plus 3 is -5. So b is -5 over 2. So then we know that our equation, let's plug that in there, is -1/2 x plus -5 over 2. So let's just erase that plus and then just call it a -5 over 2. Because remember, a plus and a negative is the same thing as a negative. So I just replaced it by one negative. All right, so that's our equation. But of course, it doesn't match up with what we have here, right? It doesn't match up. So we got to manipulate it. So let's do that now. So let's rewrite the equation. And first, what I'll do is let's move the x over to the other side. So let's do 1/2 x, because this is a -1/2 right now. So let's put the x first and then the y second. And then bring this down. Remember, we want to get rid of the denominator, so I'm going to multiply both sides by 2, that same denominator. So 2 over 1. 2 times 1 is 2. 1 times 2 is 2. 2 over 2 is 1. So this is going to be 2 over 2x, which is 1x. Or x. Distribute the 2 to y. 2 times y is 2y. Again, put this over 1, multiply straight across. That's going to be -10 over 2. 10 divided by 2 is 5, so -5. So this is my answer. X plus 2y equals -5. Oops, let's see. I want to make sure that I did the problem correctly. I must have made a mistake here somewhere. Okay, so there's a typo in this question right here. This should say -5, not -2. I apologize for that. Just a mistake in the multiple choice. So yeah, so this is correct. It's x plus 2y equals -5. So the answer is D. So I'm glad I was able to check that, verify that. All right, the next one. We have given the points A, -1, 2, and B, 7, 14. Find the coordinates of the point P that partitions the line segment from A to B in the ratio of 1 to 3. So so first off, what you want to do is to do the steps here, you have to figure out how far is it from A to B in the X direction, and then how far is it from A to B in the Y direction, okay? So you got to find what we call our horizontal distance. Okay, so we got to figure out our horizontal distance, or our distance in the X direction. And in order to do that, remember, you have to subtract the x's. So you do the absolute value, and then you subtract the x values. The x values are -1 and 7. And so this is going to be -8, and an absolute value of -8 is 8, okay? Then you want to do your vertical distance, so you're going to subtract your y values here. So 2 minus 14, which is -12, absolute value of -12 is 12. Okay, so that's your horizontal distance and your vertical distance. And then you want to do your change in your horizontal distance. So you want to do the horizontal change, otherwise known as delta x, or change in x. Okay, so but I'll just call it horizontal change. So horizontal change is equal to, So what you have to do is multiply each of those numbers by the fraction of the ratio. So here you're going from A to B. So that means that this here has to do with A, this here has to do with B. Okay, so in order to convert that to a fraction, well, if you're breaking something up into 1:3 ratio, well, that means that you have a total of 4 pieces. You would add these pieces together. So 1 plus 3 equals 4 pieces in total. So for example, if I have A and B like this, right? This is A and B, and I break it into a 1:3 ratio, well, that means I have 4 pieces just like this, and this is my 1:3 ratio. Okay, so that's what it means to the 1:3 ratio, which means you have 4 pieces in total. So that means our fraction is, we have to write this as a fraction, is 4 in the denominator and 1 in the numerator. That means that if we're breaking something up into 1:3 ratio, that means that 1/4 of the way of the entire line segment is this point right here. That is 1/4 of the way. It's 1 piece away from A out of a total of 4. Okay, so that's 1/4 of the way, and so we need to. So that's our fraction. We need to multiply this by 1/4. Okay, and then this guy, vertical change, we're going to multiply that 12 that we got times the fraction 1/4. So 8 times 1/4. So this is basically 8 divided by 4. So 8 divided by 4 is 2. This here is 12 divided by 4. 12 divided by 4 is 3. So our horizontal change is 2. Our vertical change is 3. I'm going to color code this because we're going to add those to the coordinates for A. We're going to add this to A. Well, we're going to add the vertical change to that and the horizontal change to that. So the coordinates of our new point is going to be -1 plus the change that we got for horizontal, which is 2, comma, and then the 2 from A plus the, and then we have to figure out, okay, well, from A to B, am I going up or am I going down? Okay, so what I'm going to do is I'm going to draw this real quick. Just draw a quick diagram. A is -1, 2. See how easy that is? You just draw it real quick. B is 7 and 14, somewhere around here. So this is B, this is A. The reason I need to draw it is because it gives me an idea what's going on. So I'm going from here, right, and then up. And so that means I need to add here and here, okay? That tells me that I need to add. So now we have 2 plus, we're going to add the vertical change, which was 3. So -1 plus 2 is 1. 2 plus 3 is 5. And there's my coordinates, right? Now, if, for example, I drew this line segment, so this is important here. If I were to draw this line segment and instead A was here and then B was here, if B was there, well then now that changes the scenario. I have to go right and then I have to go down. Okay, so I'm going to be adding to the X, but I'm going to be subtracting for the Y. Okay, so then this will be negative, all right? So you just got to be very careful with what direction you're going in. All right, so given segment AB, if A is -2, 4, and B is 7, -2, find the ratio that partitions the line from A to B, and then they give you the coordinate for P. So let's draw it out. Like I said, it's useful to visualize what's going on, and it doesn't have to be a very fancy diagram, just to figure out where things are. 1, 2, 3, 4. So that's P, or that's A. And B is 7, -2, 1, 2, 3, 4, 5, 6, 7, 1, 2. So B is somewhere around there, okay? It's just an estimate. And P is 1, 2. So this is P. And there's my line segment. So P is definitely not cutting this in half. So it's not a 1-to-1 ratio. It's 1 and then something else, okay? So what is the ratio that partitions this? Well, you can kind of guess what it is by looking at the diagram, because I have a nice visual now. How many of these pieces can I fit on the other side? Well, it kind of looks like I can fit 1, 2 more, right? So it looks like I can fit a total of 3 of those red pieces. So this is probably going to be this is 1, and then this is a 1 ratio here. This is a 2 pieces. So this looks like a 1 to 2 ratio. That's actually one of our answers. And from A to B, right? From A to B. So from A to B it's a 1 to 2 ratio. All right, so let's see if that's right though. I'm thinking that it's 1 to 2 ratio, but let's verify that. How would we do that mathematically? Well, first, what we need to do is figure out the change in the x. So figure out how far is it. So let's do the horizontal distance. Horizontal is x, so we got 7 minus -2. Don't forget the absolute value. That's going to be 9. The vertical distance is the y's. So -2 minus 4 is absolute value of -6, which is 6. So, okay, so we got 9 and 6. And then, and actually, we only need one of them. I did both of them, but we only need one of them. So let's just focus on the horizontal distance. We only need to do one of them. So we know that this distance from here, the distance from this point in A to this point in B, that's the horizontal distance that I found, is 9. So that's 9. So now we got to figure out, well, what's the horizontal distance for P from A to P? So what is that distance? Okay, so, well, we just got to subtract the coordinates for the x coordinates for A and P. So the horizontal, so this is the horizontal distance from A to B. Now let's do the horizontal distance from A to P. And I'll just put that there just so that we know it's from A to P. So it's going to be absolute value, -2 minus 1. I'm using those coordinates I circled in purple. And that's going to give us 3. So the distance here is 3. So then what's the ratio? So the ratio here is 3 to 9, right? 3 here, 9 there. So it's a 3 to 9 ratio. Okay, so it's a 3 to 9 ratio for this to this. However, what kind of ratio is it from here and then here? Because this is what we want. We want this ratio. Well, if the whole thing is 9 and this is 3, well then this is 6, okay? So this distance is 6, this distance is 3. So that is what we're interested in. We want to figure out what is that distance, 3 to 6. So that's a 3 to 6 ratio. Okay, so 3 to 6 ratio, if we divide that by 3, that actually reduces to a 1 to 2 ratio. So this actually checks out with what we have here. So be very careful when you're dealing with ratios. Here we're dealing with A to P and then from P to B. And so that distance is a 3 to 6 ratio or a 1 to 2 ratio. All right, so it does work out that it's a 1 to 2 ratio. So the final answer is B. Okay, given the segment with those coordinates, it says it partitions the segment in a 2 to 3 ratio. What is the coordinate of point B? Okay, so this one's interesting because now you're trying to figure out the coordinates of point B, given that something broke the segment in a 2 to 3 ratio. So this one's an interesting problem. All right, so let's go ahead and get started then. So because we're working backwards, let's go ahead. We're gonna have to be very careful with, just kind of explaining what's going on with this problem, right? So we have A is -3, -5. I'm going to go ahead and label this, draw this more carefully this time. Okay, so that's A, this is P, and then B is somewhere off in the distance. We don't know. So we know that P is two away from A, right? Because this is saying it divides a segment. That's your A to B ratio, right? So P is 2 away from A, but it's 3 away from B, like that ratio, okay? So 2 parts away. So B is 2 parts away from A, but 3 parts away from D, or from B. So, for example, this is 2 parts away, right? 1, 2. So this will be the quick way of doing this, and I'm going to show you the other way of doing this, okay? So since we know P is 2 parts away, well, this is 2 parts right here. And then if I were to extend each of these a little bit more, would that be 1, 2, and then 3. So B is probably somewhere around here. All right. And then we can get as close to the answer as possible. It looks pretty close to 5, 0, and maybe 4, -1, but I would say it's closer to 5, 0. Based off of this, 1, 2, 3, 4, 5. Yeah, this is 5, 0. So it's probably closer to 5, 0. You know, based off of my drawing, of course. But let's go ahead and show you how we would do it. So if P is 2 parts away, B is 3 parts away, right? The whole thing is 5 pieces. So if P is 2 parts away from A, well, that means that P is 2 over 5 of the way from A, right? Because there's 2 pieces plus 3 pieces is 5 pieces. So P is 2/5 of the way from A. And they told us the coordinates of A and P. So what we need to do is, here, let me go ahead and write down the coordinates for A. So what we need to do is figure out the distance from A to P and from P to A, because that's going to help us find the distance here and the distance here. So that's our goal, is to move from A to where B is at, okay? But in order to do that, I need to figure out the distance from A to P and then the distance from A to P and the Y. Okay, so let's go ahead and calculate this horizontal change. So this would be the horizontal change. And then this would be the horizontal, or the vertical change, so VC. So let's calculate the the horizontal. Yeah, so we'll just call it yeah, let's just call it horizontal change. That's fine. So just so that we have something to call it. So the horizontal change here is the distance from A to P. So this is going to be A to P here. Is going to be, well, you got to subtract the x coordinates for A to P. So it's going to be 0.2 minus -3. Don't forget the absolute value. And that's going to give you 3.2. All right, so that gives us our horizontal, I guess you can call it horizontal distance, horizontal change. I'm just going to call it horizontal change. And then here for the vertical change, it's going to be equal to, you got to subtract the y coordinates now, so -3 and -5. So -3 minus -5 is going to give us, this is a positive here, so -3 plus 5 is 2. All right, so our vertical change is 2. Our horizontal change is 3.2. And so what we want to do now is we want to figure out what this total distance is. I'll just call it total vertical distance, or total horizontal distance, I guess. And then I'll call this total vertical distance, just so that we call it something. All right, so to get that total horizontal distance from A to B, right? Well, what we have to do is, well, we know now that from A to P, it's equal to, A to P, it's, in the horizontal is 3.2. So what we need to do is we need to take 3.2, and if we multiply 3.2 by, oops, not 3.2. So we need to take the fraction, okay, so we know that 2/5 of the total distance So 2/5 of the whole thing has to equal, so we know that 2/5 of this has to equal this. This right here is 2/5 of the whole thing. So let me label this in another color. So this here is 2/5 of this, right? And so 2/5 of the total is going to be equal to the horizontal change. And the horizontal change is 3.2. So 2/5 of the total is 3.2. Likewise, if we do it for the vertical, 2/5 of the vertical, so 2/5 of this is this, right? So that is so this is 2/5 of that. So 2/5 of the total vertical distance is equal to the vertical change, which the vertical change was 2. They told us that we calculated it. So now we can get this and we can use this to solve for the total horizontal distance, total vertical distance. So this is an equation. We'll multiply both sides by 5 and then divide by 2. So we multiply by the reciprocal. These cancel, these cancel. So the total horizontal distance equals, so 3.2 times 5, this is 10, 0, carry the 1, 15, so this is going to be 16.0. So this is 16. 16 divided by 2, so this is 3.2 times 5 is 16, 1 times 2 is 2, 16 divided by 2 is 8. And then to do this guy, you're going to multiply both sides by 5/2. So the total vertical distance is equal to 2/1. 2 times 5 is 10, 2 times 1 is 2, 10 divided by 2 is 5. So the total vertical distance is 5. The total horizontal distance is 8. So now we know how much it is from A to B. So let me draw the line segment because it's very messy here. This is A, this is B, this was P. We know now that this distance is 8. We know now that this distance is 5. So that means in order to get from A to B, I need to move 8 to the right and 5 up. And so we know that A is -3, -5. So in order to move 8 to the right, I'm just going to add that to X. In order to move 5 up, I'm going to add that to Y. And then so this was my total vertical distance. This was my total horizontal distance. So -3 plus 8 is -5. -5 plus 5 is 0. And that is my coordinates for B. So notice that that was very close to what I had here in the drawing. Right here. So it's very close to 5, 0. This one's a tough problem. So, I wouldn't count it against you if you had a tough time with this type of problem. But there may or may not be one of these problems on the cycle assessment. So I wanted to make sure that we included it. So what is the last one? What is the coordinate of the point P that is 1/3 of the way from P to Q? So 1/3 of the way. So that means that we're going to divide this into 3 pieces, right? So that means I'm going to slice it 2 ways, maybe like this. And we want 1/3 of the way from point P. So our point is going to be somewhere around there, okay? You look at it, it looks like 3 and a little bit below 5. So it looks like this. However, I want to show you the work because I want to show you how we get that answer, okay? But I showed you how it is visually. So this is 1 and then there's a total of 3 pieces. So it's 1/3 of the way. But let's go ahead and show you how to do it. So we want to go from P to Q here. So we're going to figure out this horizontal distance and then we're going to figure out this vertical distance. So the vertical distance is pretty easy to tell. You just do 6 minus 2, which is going to be 4. And then the horizontal distance, you're going to do 7 minus 1, which is 6, okay? So we got those guys. And next we want to multiply each of those guys by 1/3, okay? So the vertical change is going to be 1/3 times 6. And then 6 divided by 3 is 2, okay? And then vertical, that was the horizontal, I apologize. That's the horizontal change. We'll call it horizontal change. And then the vertical change is 1/3 times 4, which is 4 divided by 3 is, so this is going to be a fraction, 4/3. And 4/3 is about 1.33, okay? So that's going to be my horizontal and vertical change. Now notice that in order to go into the line segment, I would have to go right and down, right? So right is positive, down is negative. So I'm going to have to add the horizontal and subtract the vertical, right? Subtract here and add here from the point P, okay? So the coordinates of P are 1, 6. So I'm going to add to the X coordinate my horizontal change, and I'm going to subtract from the Y coordinate my vertical change because we're going down the line segment. If you did that, you're going to get 3. 6 minus 1.33. And I want to verify this for a second, real quick. Okay, and then 6 minus 1.33 is it's about 4.67. All right, so clearly the closest one to that is the one that we chose here. All right, that might be a typo. It should probably say 4.67 because I went and verified the problem, and this is correct. So I think that may be a typo in that answer for part Y. But either way, that's the closest answer to this. So even if you got this far, you know that that's the answer. Based off of the way I showed you, it is almost to the 5, but not quite there. All right, guys, that is it. This is a long video. Like I told you, there was like 20 something problems here. But hopefully you were able to get through it and you learned a few things, or you kind of refreshed your memory on a few things. Take care, guys, and I'll see you in the next one.